Good afternoon, everyone. So last class we had a brief introduction to the subject of geography. We also studied about few concepts related to the cosmology. So that includes shape of Earth, geoid, evidences to prove the spherical shape, and then latitudes, longitude, great circles, rotation, revolution. Okay, यहाँ तक बात हुआ था, right? Any doubts here? All clear? So let's go ahead. So we're discussing regarding rotation. There are a few more things related to rotation. So to describe rotation, we need to understand there's one parameter, the period of rotation. What do you mean by period of rotation? Period of rotation का मतलब क्या है? Any body which is rotating, you want to calculate the period of rotation. What is period of rotation? Okay, the time taken by an object to complete one rotation. One rotation means 360 degrees of rotation, right? A body which is rotating, okay, so if it is continuously moving, at regular intervals it covers certain angle. The time taken to complete 360 degrees of rotation is what is called as period of rotation. Is that right? Yes or no? What is the period of rotation of Earth? (23 hours, 56 minutes). Good. And what is 24 hours? 24 hours क्या होता है? हम दिन को क्यों 24 hours बना दिया? No. Round off नहीं किया. Concept of time is based on this only. राउंड ऑफ करने का ज़रूरी नहीं था. अगर 23, 56 है तो उसी को ही होल फिगर बना के फिर उसको 24 में डिवाइड करके उसको 60 में डिवाइड करके ऐसे कर सकता था, बट ऐसा नहीं किया उन्हें. 23 hours 56 minutes is the time taken by the Earth to complete one rotation, that is 360 degrees of rotation. But still we count the day as 24 hours. Why? Because 24 hours is the time taken by the Earth to see sun back at the same position. The time taken by the Earth to see sun back at the same position, that is what is 24 hours. 24 hours is not the period of rotation. That is different. Period of rotation is different. 24 hours is the time taken to see sun back at the same position. That is what we call it as solar day. A solar day is equal to 24 hours. 24 hours is time taken to see sun back at the same position. (23 hours 56 minutes is sidereal day. Sidereal day is 23 hours 56 minutes. That is the time taken to complete 360 degrees of rotation. Time taken to complete 360 degrees of rotation. So that means that when Earth complete 360 degrees, it will not see sun back at the same position. Is that right? If it sees sun back at the same position, then we would have said 23 hours 56 minutes is solar day. 23 hours 56 minutes would have been both solar day and sidereal day. Sidereal day is period of rotation basically. Sidereal day is the time taken by the Earth to complete 360 degrees of rotation. When the Earth completes 360 degrees of rotation, the sun is not at the same position. Okay, I'll give you a demonstration, mate. Imagine myself Earth. Okay, this camera is sun. Fine, the camera is here, this is sun. And I start to rotate. If I complete 360 degrees of rotation and come back to the same position of camera, I have completed 360 degrees or not? Yes. I am also seeing the sun at the same position or not? In this case, the sidereal day is equal to solar day. Sun is back at the same position. Okay, so but it doesn't happen like this. Why? Because Earth is not just rotating, it is also revolving around the sun. As the Earth completes 360 degrees, by the time Earth completes 360 degrees, Earth's position would have changed from here to here. When I complete 360 degree, I am oriented in this point, not towards the sun. यहाँ तक आने में कितना टाइम लगा? 23 hours 56 minutes. After completing 360 degrees, I am here at 23 hours 56 minutes. This is what is period of rotation. This is what is sidereal day. You want to see sun back at the position, what I have to do? I have to rotate a little bit more. You need 4 minutes more for that. This is what is solar day. To see the sun back at the same position is solar day. For that I need 24 hours. Okay, so that is what is explained here. By the time Earth completes 360 degrees of rotation, चलो इससे बेटर एक वीडियो है वो दिखाता हूँ आपको, उससे समझ आएगा.
A day on Earth is a deceivingly simple concept. Today we'll examine prize spin 360 degrees on its axis. Or is it 361? Here is a simple model showing the Earth, the Sun, and some background stars. The Earth travels around the Sun in an ellipse, with the Sun at one focus. The model, of course, is not to scale. Let's begin our examination at noon one day. The sun is directly above the red line. That will be our reference point. Watching from a high vantage point, we see the Earth complete 360 degrees of rotation. But during that time, the Earth has also moved a bit in its orbit. So even after a 360-degree turn, the sun is not directly above the same point on Earth that it was at the beginning of the spin. It is not noon of the next day. The red reference line needs to spin a little more than 360 degrees to get us to noon. The 360-degree rotation is called a sidereal day, while the noon to noon rotation is called a solar day. To noon rotation is called a solar day.
What the point? This was our original position. Okay, here we had imagined a reference line. We started the movement of Earth from here. Okay, so when Earth moved from here to here, when it came to this position, so as the Earth rotates, the position of this arrow keeps changing, right? It keeps changing. Okay, it keeps changing and comes back to the same position here. When Earth came from here to here, it rotated and it has completed 360 degrees of rotation or not? यहाँ से यहाँ तक तो हो गया 360 degrees. Okay, but here when the Earth was oriented in this manner, the sun was exactly overhead. Here it is not overhead, you are seeing somewhere else. To see sun exactly overhead, you have to rotate a little bit more. During that time, Earth moves a little bit ahead. You are oriented in this direction now. You are seeing sun back at the same position. It started from noon, 12 o'clock. Here again noon, 12 o'clock. This is 24 hours. But before that only you had actually completed 360 degrees of rotation. At 23 hours 56 minutes you would have completed 360 degrees of rotation. Here to here, 23 hours 56 minutes, sidereal day, that is the period of rotation of Earth. Here to here, 24 hours, you will see sun back at the same position. That is solar day. Solar day equals 24 hours. Clear? So another important characteristic feature of rotation, the speed of rotation. That means what we calculate was the period of rotation. How will you calculate the speed of rotation? What do you mean by speed? Distance by time? In case of rotation, will you be able to calculate the distance by time? Speed होता है, angular velocity होता है, the angle covered divided by time. Okay, that is 23 hours 56 minutes divided by 360 degrees divided by 23 hours 56 minutes. That is the angular speed of Earth's rotation. Okay? Angular speed of Earth's rotation remain the same in every latitude. Is it right? Because every latitude has to complete 360 degrees in 23 hours 56 minutes. Right? Every latitude, whether you are located at equator or 30 degree, 60 degree, 70 degree, 90 degree, anywhere, in 23 hours 56 minutes, you will complete 360 degrees. So the angular speed remains the same. However, the linear speed changes. How will you calculate the linear speed? Linear distance divided by time taken. Here the linear distance during the rotation is actually the circumference of that particular latitude. If you are standing here in 23 hours 56 minutes, you would have traveled the distance equal to the length of equator. Okay, you would have gone like this and come back. In 23 hours 56 minutes, you would have traveled the distance equal to length of equator. If you are standing at this latitude, let's say 30 degree north latitude, in the same 23 hours 56 minutes, you will travel the distance equal to length of 30 degree north latitude, which is of course smaller. You come here, again the distance is less. Here the distance is less. Here the distance is 0. In 23 hours 56 minutes, you have traveled 0 distance. So if you want to calculate the linear speed of rotation, linear distance divided by time taken, that is maximum here at the equator and 0 at the poles. Is that right? The linear speed of rotation of Earth is maximum at the equator. It comes to be 1650 km per hour and decreases to 0 at poles, both North Pole as well as South Pole. In both the cases, it is 0. That is what is linear speed. Angular speed is same everywhere. Every latitude angular speed is same. So the linear speed of Earth's rotation is maximum at the equator, right? It is 1650 km per hour. Can you imagine 1650 km per hour? It's a very, very high speed. Okay, much, much faster than jet aircraft. Why do we not feel this speed of rotation? Itna high speed, why do we not feel that? Because of gravity. Gravity holds us back. Okay, and also because of the precision at which the Earth is rotating. You will feel the speed only when there is increase or decrease in the speed. When acceleration happens, you will get that push. When there is a break, then you will go ahead. Then only you will feel that speed. Earth rotates in such a precise manner. Okay, we will never feel that. So suddenly, if it applies brake, what happens? We are all thrown into the space. Suddenly, if gravity becomes 0, we will move at the speed of 1650 km per hour into the space. Right? So that is why rockets are launched closest to the equator. Okay, so gravity is same everywhere. Okay, gravity is same everywhere, but near to the equator there is an initial momentum. Near to the equator there is an initial momentum. Near to the poles there is no zero momentum. Okay, there is no momentum. Near to the equator, there is a very high momentum. That initial thrust, initial push is there. If you overcome gravity here, your initial momentum will throw you into the space already. Okay, so if you launch a rocket near to the equator, what happens? Even if a stationary rocket, you have put it in the launch pad, that rocket is already in motion at the speed of 1650 km per hour. Pata nahi chal raha hai bas. The rocket will burn the fuel to overcome gravity. As it overcomes the gravity, it just thrown into the space. There is a greater push. If you launch the same rocket near to the poles, even if you overcome the gravity, the rocket is still stationary only because it was not moving only, right? Then you have to burn extra fuel to move it. So therefore, rockets are launched closest to the equator. You are located anywhere in the northern hemisphere, you come closer to the equator. You are located anywhere in the southern hemisphere, again you come closer to the equator. The rockets are launched closest to the equator because of the greater initial push, initial thrust. So by launching at the equator, you get a greater thrust. So therefore, you can launch a rocket with lesser fuel. Near to the equator, you can launch a rocket with lesser fuel. That is why most of the countries prefer their location. If you want to launch in your own country, it is your own country's southernmost location. That means nearest to the equator is always preferred. Or southern hemisphere mein hai to northernmost location. Okay, for example, USA. USA southernmost location is here, near to the tip of Florida. That is where they have John F. Kennedy Space Center. Okay, from where they launched Apollo missions. Okay, so what about India? India ka southernmost location. Where is India's rocket launching site? Sriharikota. Here. Why do we not use Kanyakumari? That is much more southern. Because of rotation of Earth. Whenever you launch a rocket, it always gets launched in this direction only. Okay, Earth is rotating like this, right? It always gets launched in this direction. That is why it is always the eastern coast which is preferred. Okay, so tip of Florida is eastern coast. Sriharikota is also eastern coast. If you launch from here, if it fails, it will fall in Sri Lanka. To avoid that. Okay, so it has to be southernmost, at the same time it has to be the eastern coast. There should be enough water. Okay, so from here, you could have taken any location. Sriharikota was an island. Strategically also it's better. Okay, better to manage the security and all. So isliye they chose Sriharikota. Very near to Chennai also. Okay, logistics, human resource, everything is easier. Okay, so that is why we chose that. And there's one location in South America, Cairo. Cairo is a location in French Guiana in South America, located exactly near to the equator. Many countries which are very far away from the equator, they will not be able to launch nearer to the equator, right? So they come here to launch. Okay, so many countries who are not able to come nearer to the equator, उनका overall country बहुत दूर है, equator से बहुत दूर है. Okay, so they come here to launch. French Guiana, Cairo. The best location in the entire world to launch rockets because it is located exactly equator and along the eastern coast. Okay, so you will have the least fuel. You will spend least fuel to launch it here. And they made it commercial, right? Totally commercial. Of course, you have to give money. Free में तो नहीं करने देंगे. Okay, so many countries go across the world to launch their rockets here, and even India used to launch. Till recently, we used to launch from there. Okay, so till we develop GSLV, which is capable of launching heavier satellites and up. So till then we used to launch from here. But why people spend so much of money, energy, fuel to transport their components to Cairo and launch from there just to save from rocket fuel? Let's say European countries, they have to cross the Atlantic Ocean, come this way and launch from here. Just to save some rocket fuel. Why? If you launch near to the equator, you will take lesser fuel, right? Why? Spend some more fuel over there in your country only and you launch it. Because you are spending more time and more money here to transport them. Huh? Water? ठीक है, फिर अटलांटिक ओशन कहीं पे मेडिटेरेनियन सी में करो. Why there are more chance of success? Because of? Why there are more chance of success near to the equator? Because of lesser fuel. Lesser fuel, lesser weight, greater chance of success. You know, in rockets, they count each and every gram. Each and every gram is counted. Okay, so जितना weight बढ़ाओगे उतना chances कम होते जाएगा. Heavy rocket launch करना बहुत मुश्किल है. Because heavy rocket के लिए heavy fuel चाहिए, ज़्यादा fuel चाहिए, फिर fuel के हिसाब से oxygen भी चाहिए, ज़्यादा बढ़ते जाएगा. Overall weight of the rockets keep increasing. It's not about saving fuel, it's about greater chances of success. With less fuel comes greater chance of success. Lighter rocket is always successful. That is why. That is regarding speed of rotation of Earth. Let's talk regarding seasons. Seasons के बारे में बात करते हैं. What are seasons? What do you mean by season? Yes? Changes in weather condition is season. What do you mean by summer season? Okay, that is the cause of season. That is cause of season. What is season? Tell me that first. Season का मतलब क्या है? How many seasons are there geographically? What are they? Spring, autumn, summer and winter. Okay. What about rainy season? Is there a season called as rainy season? Locally, in some places. Season is a general word which is used in various different contexts. Geographically, we have 4 seasons, fine. But otherwise, season is a very general word. For example, we use IPL season. IPL season होगा? अभी चल रहा है शादी का season. Okay, so फिर मच्छर का भी सीजन है say that, huh? So we say IPL season but not World Cup season. Why? Have you heard somebody saying World Cup season? No. Why? Particular period of time? Complete? In a year. It has to be repeated every year, then only we call it a season. Okay, it has to happen in particular time of the year. In the specific time of the year it has to happen, then only we call it a season. When we say शादी का season, इस time में शादी होते हैं, बहुत ज़्यादा शादी होते हैं, इस time आ गया तो वो शादी का season आ गया. Okay, we have mango season, particular time of the year where you get mango, right? So particular time of the year when we have IPL played, IPL season. World Cup is not played every year. Therefore, it is not a season. Okay, season is something which happens every year during that particular time only. A summer season is the time of the year during which we observe hot weather conditions. A winter season is that time of the year during which we observe cold weather conditions. Spring season is the time of the year during which the trees rejuvenate their leaves. Autumn season is when they shed their leaves. Season is a particular thing happening in a particular time of the year. Okay, if the change of season, if it is changing randomly, we won't call it a season. Okay, इस बार समर हुआ था जून जुलाई में, so next year दिसंबर जनवरी में हुआ था, तो उसको हम सीजन नहीं बुलाएंगे. Okay, it has to be periodic, it has to be repetitive, it has to be predictable. Then only we can call it as a season. So geographically, seasons, it is the particular time of the year during which we observe specific weather conditions. Fine? That is what is seasons. What do you observe during summer weather condition, summer season? Summer season में क्या होता है? High temperature. Winter season, low temperature. Spring is moderate temperature, autumn is moderate temperature. Okay, why do we observe hot weather conditions during summer season? Any of you have thought about this? Why the summer is hot? What causes hot weather conditions? Amount of insulation increases. Okay, then? So what happens? What happens? Tell me. What happens during summer? Two things. Most of you would have observed this. One is length of the day is longer. Length of the day is longer during summer. Normally if it is 12 hours, during the summer it is 13 hours, 14 hours, 15 hours, 16 hours, depending upon the location. Length of the day is longer during summer. Second is intensity of sunlight is also higher. What do you mean by intensity? In a unit area, how much of sunlight is falling? Intensity of sunlight is higher in the summer. During the winter, length of the day is shorter. Late sunrise, early sunset. That is what we are seeing now. 7 o'clock sunrise hoga. 5 o'clock sunset. Fine? Intensity of sunlight is also low. In a unit area, the amount of sunlight falling is also less. Okay, so during the winter, people wait to go out in the sun in the afternoon. दोपहर कब होगा, सन कब निकलेगा, ओके बाहर जाते हैं, तब वो धूप लेते हैं. Okay, we wait for that. In the summer, you want to avoid afternoon. Okay, 12 बजे जाके देखो. Okay, दिल्ली में तो फ्राई हो जाओगे. Okay, length of the day is longer. Intensity of sunlight is also longer. There is a high intensity. The same afternoon, you will have a very high intense sunlight. Here during the winter, there is a low intensity sunlight. Length of the day is shorter. That is what is summer and winter. When the length of the day is longer and intensity of sunlight is higher, obviously you feel higher temperature. When length of the day is shorter, intensity of sunlight is lower, obviously you will feel lower temperature. Okay? There is a gap of 6 months between summer and winter. In between, the length of the day decreases gradually. You would have observed this. From the peak summer, June 21st, okay, length of the day starts to decrease. Every day, sun starts to rise little bit early. It starts to set little bit early. Sun starts to rise little bit late, sets little bit early. Gradually. By the time you reach the peak winter, you will have the shortest day, right? Shortest day will be there and lowest intensity of sunlight. In between, it is gradually decreasing. In between comes one point where the length of the day is not too high, not too low. Intensity is not too high, not too low. This moderate position is what is called as equinox. The same position comes here also. When the earth was moving from winter to summer, in between there is a moderate position where the length of the day is not too low, not too high. Intensity of sunlight is not too low, not too high. That is also equinox. Coming from summer to winter and winter to summer to winter, in between, the trees will start to shed the leaves. Because, why? Because the trees have better common sense than human beings. Because there is a shortage of water in the winter season. Winter में थोड़ा बहुत पानी कम होता है, चलो let's save some water. We don't have that common sense, right? It will start to shed the leaves. To save water, it will start to shed the leaves. That is what is autumn, autumnal equinox. Now you are moving towards summer, there is an increasing availability of water, so it will start to bring back the leaves. That is what is spring. These are the 4 seasons. Rainy season is not a universal. It is not throughout the earth the same time. In some places, the rain happens in the month of summer, for example, India. In some places, rain happens during the month of winter, for example, Mediterranean region. In some places, rain occurs throughout the year, for example, equatorial region or British climate, London. Fine? So it varies. So it is not a geographical global season. It is only local season. So what changes during the seasons? Length of the day and intensity of sunlight. These 2 things changes during the season. Now what causes them to change? That we will see. Okay? So write the definition of seasons. Seasons are distinct periods of the year. Characterized by specific weather patterns. Characterized by specific weather patterns. So summer, longer length of the day, higher intensity of sunlight, causing high temperature. Winter, shorter length of the day and lower intensity of sunlight, resulting in low temperature. Spring and autumn, moderate length of the day, equal length of the day, equal length of day and night, and moderate intensity of sunlight. So it is basically length of the day is changing, intensity of sunlight is changing, that is causing seasons. Right? Now let's see what is causing them to change. Why the length of the day is changing, why the intensity of sunlight is changing. For the sake of simplicity, let's assume that Earth is totally straight in its overall tilt. There is no tilt. Imagine there is no tilt. Okay, so here there is another phenomena called as circle of illumination. What is this circle of illumination? The line which divides the regions of day and night. On the globe, the line which divides the regions of day and night is what is called a circle of illumination, because this line becomes a circle, right? ये पूरा circle हो जाता है. On the behind side there is night, on this side there is day. Sunlight is continuously coming in this side. Okay, just imagine. There is this circle of illumination. And as Earth rotates, every place will go through night and then day, night and day, like this continuously. It changes its position. Okay, observe here. Here, let's say this is the axis of rotation, Earth's axis of rotation. Just imagine. And this is circle of illumination. In this position, both of them are coinciding. The axis of rotation is coinciding with the circle of illumination. What happens to length of day? Okay, try to observe here. How will you check the length of the day? By seeing how much of area is there under day and then at night. Okay, you take one particular latitude. Okay, let's say you are standing here. Okay, so okay, leave about this. Let's say you are standing here in this position. Okay, so this is how the Earth is there. You're standing here. The sunlight is coming from here. When you look from here, this is what is sunrise for you. Okay, when you come here, this is noon for you. When you go here, this is sunset for you. Okay, so this is the day portion for you. And as the Earth rotates, your position comes back to here. This is one rotation. When Earth completes one day, 24 hours, you are in day for 12 hours, night for 12 hours. Can you see the length of the day? That you can check very easily by measuring this distance. During this entire portion, you are in the day. During the other side, you are in the night. This is night. If both are equal, that means 12 hours of day, 12 hours of night. Check their length. Both are same only. The duration for which you are in the day is same as the duration for which you are in the night. 12 hours of day, 12 hours of night. Can you check here? Here also it is same. Here also it is 12 hours of day, 12 hours of night. 12 hours of day, 12 hours of night. Because Earth is rotating straight. There is no tilt here. Okay, imagine in this scenario. In this scenario, if it is rotating, here also there is 12 hours of day, here also there is 12 hours of night. 12 hours of day, 12 hours of night. 12 hours of day, 12 hours of night. 12 hours of day, 12 hours of night. Same here also. In every latitude, you can clearly see that the length of the day is equal to length of the night. Fine? What about intensity of sunlight? The intensity of sunlight is maximum at the equator because that is where it is falling totally 90%, 90 degrees. Intensity of sunlight depends upon the angle of incidence. ये तो पता है ना? When the sunlight falls straight, it occupies smaller area. The sunlight falls at an oblique angle. Okay, same sunlight when it falls at oblique angle, can you see it occupies larger area? The same sunlight is occupying smaller area, higher intensity. The same sunlight occupying larger area, lower intensity. Intensity of sunlight depends upon the angle of incidence. The angle of incidence is 90 degree at equator. Equator is experiencing highest intensity. The more you go towards higher latitude, intensity decreases because the angle of incidence is decreasing. Near to the poles, can you see it is just spreading out. The sunlight is almost grazing the surface. Very, very low intensity. Same is the case with southern hemisphere. The more you come towards the poles, the intensity of sunlight is decreasing. In this scenario, length of the day is 12 hours of day, 12 hours of night everywhere, and intensity of sunlight is highest at equator and decreases uniformly towards both North Pole as well as South Pole. Let's bring tilt in this picture. इसको tilt करके देखें. Here you can very clearly see that when we tilt, the axis of rotation will not coincide with the circle of illumination. Axis of rotation will not coincide with the circle of illumination. Let's try to calculate length of the day here. At equator, still it is 12 hours of day and 12 hours of night. At equator, there is no change. Fine. Earth is rotating like this, but here it goes for 12 hours here and then 12 hours here. Because equator is the only location where both of them are coinciding. You come towards higher latitudes, let's say at 30 degrees. From 12 hours it has expanded to include more sunlight. Length of the day has increased, length of the night has decreased. From 12 hours it has become 16 hours of day, 8 hours of night. Right? और ऊपर आइए. 20 hours of day, just 4 hours of night. As the earth rotates like this, for 20 hours it is in day only, and only for 4 hours it is in night. Beyond Arctic Circle, 24 hours of day. Because the sunlight is reaching till this point. The entire part is under the sunlight for 24 hours. Okay, you completely rotate this entire part never goes off the sunlight. Sunlight is always there for 24 hours. 24 hours of day. Is that right? Come to the southern hemisphere. Length of the day has decreased, length of the night has increased. 8 hours of day, 16 hours of night. 4 hours of day, 20 hours of night. "24 hours of night." Because the last sunlight has stopped here only. यहीं पे खत्म. इसको जितना भी घुमाओ ये यहाँ पर सनलाइट आएगा ही नहीं. इन एंटायर 24 hours of duration, this is always under darkness. Length of day and night is distorted. There it was completely equal because of the tilt. Length of the day has increased in one side, length of the day has decreased in another side. This happens when the tilt is towards the sun in the northern hemisphere. Whichever the part tilted towards the sun, there the length of the day increases. And this part is tilted away from the sun, length of the day has decreased. What about intensity of sunlight? Intensity of sunlight is highest at Tropic of Cancer, 23.5 degree north. Because it is tilted by 23.5 degree now. When it was completely straight, at this position, equator is there. Okay, this is equator. When you tilt like this, इक्वेटर का पोजीशन नीचे आ गया, यहां पर आ जाता है ट्रॉपिक ऑफ कैंसर. 90 degree sunlight, highest intensity sunlight is falling at Tropic of Cancer. From here it decreases towards both North Pole as well as South Pole. But what is the significance here? When you tilt like this, every place in the northern hemisphere starts to receive the sunlight at higher angle. When the tilt is towards the sun, wherever the tilt has become towards the sun, the intensity of sunlight increases. Because angle of incidence increases by 23.5 degree. Is that right? कोई भी latitude ले लो, हर जगह में In the northern hemisphere, in every latitude, the angle of incidence increases by 23.5 degrees. At 23.5 degree earlier, the sunlight would have been falling at what angle? (66.5 degree). In this position, I'll tell you, right? What is the angle of sunlight here? 90. What is the angle of sunlight here? 0. At 0 degree 90, at 90 degree 0. At 0 degree 90, 10 degree 80. 20 degree 70. 23.5, 66.5. It proportionately decreases because of the curvature. At 30 degree 60. 45 degree 45. 50 degree 40. Like this, it gradually decreases. 23.5 degree, the angle of incidence was 66.5 degrees. Now 23.5 degree is receiving 90 degree. The angle of incidence has increased by 23.5 degree. Not only at 23.5 degree, every latitude. Okay, let's calculate for 60 degree north. At 60 degree north, what was the angle of incidence earlier? 30 degree. Okay, same 60 degree north is, it was somewhat like this, now it is tilted like this. Okay, so let me show this. This is how the surface was there. This is how the surface was there at 60 degree north. 60 degree north में ऐसे हो जाता है ना? This angle was 30 degrees. Okay, when you tilt like this, what happens to this surface? Surface also gets tilted like this, right? Now the surface position is somewhat like this. The angle of incidence will increase by 23.5, right? Every latitude, the angle of incidence increases by 23.5 degree. Every part of the surface, wherever it is getting tilted toward the sun, the angle of incidence increases. Angle of incidence increases, intensity of sunlight increases. Is that right? Opposite in southern hemisphere. When you tilt away from the sun, angle of incidence decreases. Same यहीं पे दिखाता हूँ देखो. At 60 degree, earlier the angle of incidence was 30 degrees. चलो ये उल्टा होता है. This was the southern hemisphere. This was the angle, 30 degrees. ठीक है? This was the southern hemisphere 60 degree, angle of incidence was 30 degrees. Okay, this was like this. इसको ऐसे घुमाए तो क्या होगा? When you tilt like this part gets tilted further like this. This is the new angle of incidence. Now this is the surface and this is the angle of incidence. Angle of incidence has decreased from 30. Will decrease by how much? 23.5. The angle of incidence decreases by 23.5 degrees. From 30 degrees it will come to 6.5 degrees. The angle of incidence in the northern hemisphere increases by 23.5 degree. The angle of incidence in the southern hemisphere decreases by 23.5 degrees. Intensity of sunlight increases in the northern hemisphere. Intensity of sunlight decreases in the southern hemisphere. With longer length of the day and higher intensity of sunlight, this is what we call it as summer. You start to feel more higher temperature, right? With shorter length of the day, lower intensity of sunlight, this is what is called as winter. That is why the seasons are always opposite in both the hemispheres. If there is summer over there, here it is winter. If there is winter over there, here it is summer. Between India and South Africa, India and Australia, the seasons are always opposite. Any of you are cricket lovers? Have you heard of test cricket played in Australia after Christmas? Boxing Day match bolte. Okay, usually that is a tradition. After Christmas, there is always a test cricket. If at all you observed, you would have seen that it is summer over there. स्वेटर नहीं पहनता है, समर है वो. इंडिया के लिए जब विंटर होगा वहाँ पर समर होता है. इंडिया के लिए समर होगा तो वहाँ पर विंटर होगा. सेम इज द केस विद साउथ अफ्रीका. Northern and southern hemisphere, the conditions are always opposite. So is this clear? Why there is summer? Longer length of the day, higher intensity of sunlight. Why there is longer length of the day? Because of the tilt. The tilt has changed. Earlier there was equal day, equal night. Now the length of the day is increasing continuously towards the north, decreasing continuously towards the south. Because of the tilt towards the sun, the angle of incidence has increased. Angle of incidence will increase the intensity of sunlight also. Higher intensity of sunlight, lower intensity of sunlight. You bring revolution into the picture, the condition gets reversed exactly. Exactly reverse हो जाएगा 6 महीने में because of revolution. Earlier we were in this position, where the northern hemisphere was tilted towards the sun, southern hemisphere was tilted away from the sun. Northern hemisphere had longer length of the day, higher intensity of sunlight. Southern hemisphere had shorter length of the day, lower intensity of sunlight. Now because of the same tilt, length of the day is decreasing in the northern hemisphere. Length of the day is increasing in the southern hemisphere. Intensity of sunlight is higher here, intensity of sunlight is lower here. Why? ऐसे क्यों होगा? Because पूरा exact reversal हो गया ना. Now the northern hemisphere is tilted away. Okay, observe. Length of the day is decreasing in the northern hemisphere. The more you go towards the higher latitudes, length of the day is decreasing. Illuminated तो इतना ही है ना. Whereas in the southern hemisphere, length of the day is increasing. The more you come towards the south, the length of the day has started to increase. And more higher angle of incidence is in the southern hemisphere, lower angle of incidence is in the northern hemisphere. Lower intensity, higher intensity. Shorter length of the day, lower intensity of sunlight. This is what is winter. Longer length of the day, higher intensity of sunlight. This is what is summer. The conditions are reversed. That happens because the earth revolves around the sun with a tilted axis whose position remained fixed during the entire revolution. If this is the tilt here, this is the tilt here, this is the tilt here, this is the tilt. That is what we call it as the fixed axis of rotation. Axis is not only tilted, it is fixed in its position. Axis will not change its position. Throughout the entire revolution, it is tilted in the same direction. इसके वजह से नॉर्थन हेमिस्फीयर इस डायरेक्शन में था, अभी सेम नॉर्थन हेमिस्फीयर उस डायरेक्शन में चला गया, अवे फ्रॉम द सन. सदर्न हेमिस्फीयर वाज अवे फ्रॉम द सन, हियर द सदर्न हेमिस्फीयर इज टुवर्ड्स द सन. So the reason is not only tilt, it is also the fixed axis. टिल्ट भी होना चाहिए, फिक्स भी होना चाहिए. अगर चेंज हो गया तो वो फिर इम्पैक्ट नहीं होगा. सीजन्स चेंज होगा, वो यूनिफॉर्मली नहीं होगा. हमें चाहिए यूनिफॉर्म चेंज, पीरियोडिक चेंज होना चाहिए, नहीं तो रैंडमली चेंज हो जाएगा फिर. Is that clear? This is summer in the northern hemisphere, winter in the northern hemisphere. This peak position is called as summer solstice, peak position is called as winter solstice. Now, in between the position comes the spring equinox and autumnal equinox. Spring equinox and autumnal equinox. In case of spring equinox, we have equal length of day and night in every latitude. That is the meaning of equinox. 12 hours of day, 12 hours of night in every latitude. Fine? That is equinox here, equinox here. How is it possible? How can we have equal length of day and night in every latitude? For that, I showed you that there was no tilt. जब tilt नहीं हुआ था तभी तो equal length of day and night था ना. So in this, remember this? When there was no tilt, everywhere the length of the day is equal to length of the night. But यहाँ पर बोल रहा हूँ मैं तो ये equinox है. How is it possible? Position of sun means? Sun is overhead at the equator. तब ऐसे होता है क्यों? What about tilt? Tilt है या नहीं है? Tilt तो फिक्स है, उसको फिक्स कर दिया हमने, उसको चेंज नहीं कर सकते. The tilt is neither towards the sun nor away from the sun. It's all about the orientation. Tilt never gets changed. The orientation gets changed. See. इसी को ही हमारा सन बना देते हैं. Okay, this is summer. The northern hemisphere is tilted towards the sun. Southern hemisphere is tilted away from the sun. Okay, summer solstice. यहाँ पर summer है, यहाँ पर winter है. This is winter. Northern hemisphere is tilted away, southern hemisphere is tilted towards. ऐसे. ठीक है? As the earth moves from here to here, as well as from here to here, can you see the position? The northern hemisphere is neither towards the sun. Southern hemisphere is neither towards the sun. Even though tilt is there, the orientation is such that it is neither towards the sun nor away from the sun. When it is towards the sun, this is summer. When it is away from the sun, this is winter. This is neither towards nor away. Same is the case here also. Right? In this position, if you see, in this position, the sunlight falls exactly at 90 degree at equator. That is what happening over there. The sunlight falls exactly at 90 degree at equator when the length of the day is equal to length of the night in every latitude. Okay, imagine. Okay, so the sunlight is here. The entire part is illuminated. So every position goes through 12 hours of day and 12 hours of night. 12 hours of day, 12 hours of night, everywhere. In every latitude there is 12 hours of day, 12 hours of night. Because both the hemisphere is equally illuminated. Here, northern hemisphere is illuminated more. Here, the southern hemisphere is illuminated more. Here, both the hemispheres are equally illuminated. That is what is equinox. Length of the day is equal to length of the night in every latitude, not only at the equator. Right? Here also. Length of the day is equal to length of the night in every latitude. And intensity of sunlight is highest at the equator. Here also it is highest at the equator. Here it is highest at the Tropic of Cancer. Here it is highest at the Tropic of Capricorn. उसको हम बोलते हैं equinox. Is that clear? So what is the reason behind the seasons? Revolution of the earth with a tilted axis of rotation which remain fixed during the entire revolution. Right? So that causes all these changes. So if we start from one position, you will let's try to understand here. Let's start from one position. Let's start from here. Spring equinox. Okay, spring is which is between the winter and summer. It is a mid path between the winter and summer. The temperature is not too high, not too low. Here, this is where our trees will start to rejuvenate the leaves. That is why in most of the cases, in most of the culture and religion, they practice New Year from here. 21st of March. Okay, in most of the places, New Year is from here. Okay, so coming from here, Earth is continuously moving in this position. Here, 12 hours of day, 12 hours of night. Highest intensity is at the equator. Here, the longest length of the day and highest intensity of sunlight. From here to here, every subsequent day, gradually things are changing. Okay, so every subsequent day, length of the day is increasing. Here the sunrise happened at 6 o'clock. Okay, after some time, 5:50, 5:40, 5:30, 5 o'clock, 4:30, maybe 4 o'clock. Every subsequent position, the length of the day is increasing. Okay, from 12 hours, it starts to become 14 hours, 15 hours, 16 hours. Okay, it reaches the peak here. Intensity of sunlight also reaches the peak here. And from here, the length of the day starts to decrease here because it comes back to 12 hours here again. From here, it starts to decrease further. Because in the winter, if it is 14 hours of day, there will be 14 hours of night. Right? Then only there is 10 hours of day. Gradually it decreases, reaches the least duration of the day and lowest intensity of sunlight, and then comes back here. That is how it changes. Every subsequent day, length of the day varies, intensity of sunlight varies. Okay, let's take one example. Let's say Delhi. In Delhi, peak summer, let's imagine this is 15 hours of day. It usually happens, 4:30 sunrise happens. Okay, peak summer. 7:30 sunset happens. Fine? 15 hours of day. Winter, 9 hours of day. 7:30 sunrise happens. Okay? And 4:30 sunset happens. Peak winter. Let's start from here. 12 hours of day. 12.5 hours. 13 hours. 13.5. 14 hours. 14.5. 15 hours of day. Every subsequent position continuously it is changing. By the time it reaches here, Delhi is experiencing 15 hours of day. From here it decreases to 14.5, 14, 13.5, 13, 12.5, 12. By the time Earth comes here, the length of the day is back to 12 hours. From here it starts to decrease. 11.5, 11, 10.5, 10, 9.5, 9 hours of day. From here again it starts to increase. 9 to 9.5, 10, 10.5, 11, 11.5, 12. That is how length of the day changes. Okay. This peak position where you have the highest length of the day, and when the orientation is also maximum, highest intensity of sunlight is also there. And that is what is called as summer solstice. Okay, peak position where the lowest length of the day, lowest intensity of sunlight, that is what is winter solstice. In between, equinox, spring equinox, autumnal equinox. You start from here, you will get the dates. March 21st is when we have the spring equinox. Usually that is what is New Year, Hindu calendar New Year, Yugadi. Okay, so or Gudi Padwa. Right? So that is New Year here. After 3 months, because 12 months, after 3 months, June 21st is when summer solstice. After 3 months, September 23rd is when autumnal equinox. After 3 months, December 22nd is when winter solstice. And then back to spring, that is March 21st. एक दो दिन आगे पीछे होते हैं कैलेंडर में. Okay, dates important है. एक याद रख लो, याद हो जाएगा सारा. March 21st, June 21st, September 23rd, December 22nd. And this length of the day, I told you, the maximum length of the day is here. That is true for every latitude. Every latitude will have its own maximum length of the day. I gave you example, in Delhi, its maximum length of the day is 15 hours. You go to Paris, maximum length of the day is 18 hours. Go to London, maximum length of the day is 20 hours. Because with increase in the latitude, length of the day increases, right? Let's see London. Okay, length of the day 12 hours, 13 hours, 14 hours, 15 hours, 16 hours, 17 hours, 18 hours. Let's say maximum length of the day is 18 hours. From 12 hours it becomes 18 hours here. 18 hours starts to decrease. 17, 16, 15, 14, 13, 12 hours back. It starts to decrease at the same rate. Okay, if 18 is the length of the day, here 18 will be the length of the night. That means length of the day will be 6 hours. From 12 hours, 11, 10, 9, 8, 7, 6. By the time it comes to here, 6 hours of day. Okay, from here it starts to increase. 7, 8, 9, 10, 11, 12. Every place will have its own length, maximum length of the day here and least length of the day over there. ठीक है? the same visualization you can see here.
It takes Earth sun in the same direction
Observe from
all
here.
year round as we orbit the sun. But that means the
This is how the
sun's light
orientation is
shines
changing
differently
from
on
equinox
Earth
to
at different
winter.
times of the year. Let's look at Earth when it's different tilted in
Can you see equal length of day and night? Everywhere the length of the day is same as the night. Every latitude. This is equinox. Okay, so let's say this is autumnal equinox. We are moving towards winter solstice.
the same direction all
observe, you
year
can very
round
clearly
as
see.
we orbit the sun.
Length of the day is
But
becoming
that
shorter,
means
shorter,
the sun's
shorter.
light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere.
At the peak winter.
Observe how the North Pole tips away from the sun. This means that sunlight
This is the peak winter. Length of the day is shortest here. Every latitude is experiencing its own shortest length of the day. In the north, equator is anyway 12 hours of day, 12 hours of night throughout there. That is why equator is called as hot and wet climate. Throughout the year, it remains 12 hours of day, 12 hours of night. It will not change. But as you move towards the higher latitudes, the length of the day is decreasing. Can you see? By the time you come to Arctic Circle, there is totally sunset. Because the entire region beyond the Arctic Circle is away from the sun. There is total darkness. 24 hours of night. That is what is called as polar day. The entire region beyond Arctic Circle is experiencing polar night. Did I say day? This is polar night. Sunlight is not at all reaching over there. Polar night. 24 hours of night. Whereas in the southern hemisphere, length of the day is increasing. It increases, 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 and all the regions beyond Antarctic Circle, it is experiencing polar day, 24 hours of sunlight. Okay, where is the highest intensity sunlight? Tropic of Capricorn. This is where Tropic of Capricorn is there. Okay, let's rotate.
light strikes the
ऐसे
northern
rotate करके देखो
hemisphere at
आपको
a
दिन कैसे
shallow
change होगा
angle
समझ
for
आएगा.
a short period of time. This is why winter weather is generally cool, with short days and long nights. As
From
Earth
here it
orbits
starts to
the
change
sun,
again.
we
It comes
move
to
towards
equinox.
spring in the northern
Here you can see
hemisphere.
exactly equal day, equal night.
Now Earth is tilted neither
Spring
toward
equinox.
nor away from the sun, as day and night are about equal in length.
90 degree sunlight is at the equator.
As we make our way to the summer months, notice that Earth is still tilted in the
This
same
is
direction,
summer
only now
solstice.
on the other side of our orbit. The North
Now the
Pole
entire
is
region
tilting
beyond Arctic
toward
Circle
the
is
sun.
totally exposed.
Sunlight
Okay, so the complete, again at the equator you can say 12 hours of day, 12 hours of night. However, with increase in latitude in the northern hemisphere, length of the day is increasing, increasing, increasing. Beyond Arctic Circle it is 24 hours. Because this entire part is completely illuminated. Whereas in the southern hemisphere, length of the day is decreasing, 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 and it is 0 hours beyond this Antarctic. Here it is polar day, there it is polar night. Higher intensity is in the northern hemisphere. So here it is summer, there it is winter.
strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates
Again, we are
the
back
different
to
seasons throughout
equinox.
the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They
Equinox.
respond to the southern hemisphere because of Earth.
So where are we experiencing polar day right now in this thing? All the regions beyond Arctic Circle, polar day, right? As the Earth's position changes, the area which is under polar day will start to contract. Polar day, what is polar day? Polar day is 24 hours of sunlight. All the latitudes beyond this part is experiencing polar day. As the Earth starts to move, Now the entire Arctic Circle is not under polar day. Only this much is under polar day. After some time. After some time, this much, this much, this much. Gradually it starts to decrease. The area which is under 24 hours of sunlight will start to decrease from 66.5 degree. Observe.
Earth's tilt, the seasons are reversed. We observed how
Can you
Earth's
see?
tilt creates the different seasons throughout the year.
So here, the sunlight is coming till here only, right? So the entire region up to this part is experiencing polar day now. Hey, nahi? Okay, so after some time,
How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend
can you see? Only this much region is exposed all the time. The area of polar day is decreasing. From the peak summer, as you come towards the equinox, it starts to decrease. Same is the case with polar night. So what is Arctic Circle and Antarctic Circle? Arctic Circle and Antarctic Circles are basically the regions up to which we experience polar day and polar night. None of the latitudes below the Arctic and Antarctic Circle never experience polar day, polar night. Okay, here you see the entire region up to the Arctic Circle is polar day. The entire region up to Antarctic Circle is polar night. You have to visualize here. When you are here, do you have polar day, polar night? Equinox में polar day, polar night है? नहीं. Okay, but if you are standing exactly at 90 degree, exactly 90 degree में खड़े हैं आप. Okay, so you are standing somewhat like this. Okay, so you are seeing the sun. Okay, ऐसा रखो. Okay, you are seeing the sun. Exactly 90 degrees में है तो there's 12 hours of day, 12 hours of night. But एक इंच इस तरफ कर लो, you will see sun for 24 hours. Slight position ऐसे shift कर दो. You can see, जितना भी rotate करो वो हमेशा sun दिखेगा. Okay, only here. After some time when you move the position, this entire region is illuminated. In this entire smaller circle, you will see 24 hours of sunlight. Because जितना भी घुमाओ ये पूरा illuminated है. After some time, till here, जहाँ पर peak position में आ जाएगा, the entire Arctic Circle is polar day. After some time, वो थोड़ा सा और छोटा हो गया. यहाँ तक polar day है, फिर यहाँ तक polar day है, यहाँ तक polar day. The maximum extent of polar day extends from 90 to 66.5 degree. यहाँ से यहाँ तक आ गया तो वो पूरा कम होके फिर दोबारा single point बन गया. But once you move away, then the polar night starts here. The area of darkness. Now the area of darkness will start to expand. As the earth moves from this position to this position, the entire area beyond Arctic Circle is not at all visible from the sun. पूरा polar night हो गया. फिर दोबारा visible होना शुरू होगा थोड़ा सा. Okay, so from here to here, the circle of brightness, that is polar day regions are expanding. Maximum आ गया, फिर वो minimum पे आ गया. From here to here, the circle of darkness, that is the regions of polar night is expanding and that becomes the maximum and then comes back to the least. So that is the limit of Arctic and Antarctic Circle. It is the maximum extent up to which you observe the phenomena of polar day and polar night. उसके नीचे तो नहीं होगा. उसके नीचे करना है तो क्या करना पड़ेगा आपको? अर्थ को और थोड़ा सा टिल्ट करना पड़ेगा. Earth is tilted by 23.5 degree, therefore the Arctic Circle gets completely illuminated. Right? If you tilt it by 30 degrees, what happens? The polar day is observed up to 60 degree north. Right? 60 degree north तक polar day दिखेगा. 66.5 तक क्यों दिखता है? 23.5 degree tilt है ना? What about overhead sun? What do you mean by overhead sun? 90 degree sunlight is called as overhead sun. 90 degree sunlight is observed at the noon. Will you observe 90 degree sunlight at noon in every latitude? At noon, 90 degree sunlight, is it observed at every latitude? There will be only one latitude in any day. Only a particular latitude experiences 90 degree sunlight at noon. And that is equator. On the day of equinox. Tropic of Cancer on the day of summer solstice. Back to equator on the day of equinox, autumnal equinox. And then Tropic of Capricorn on the day of winter solstice. The 90-degree sunlight, overhead sun, continuously changes its position. Okay, so you experience overhead sun in a particular latitude only for one day, because the sun's position will not remain the same. आज का overhead sun कहाँ पर हो सकता है? एक particular latitude होगा. Next day next latitude, next day next latitude, ऐसे change होते जाएगा. Because 90-degree sunlight always changes from equator to Tropic of Cancer, Cancer to equator, equator to Capricorn, and then back to equator. That is continuously shifting. What happens whenever there is an overhead sun? In any location, if there is an overhead sun, there will not be any shadow over there. At noon, there is no shadow. So, it is also called as the no shadow day. The position of overhead sun, wherever it is, overhead sun is there, there is no shadow at noon. Okay? So, now tell me. Okay, let me draw equator, and this is Tropic of Cancer. Let's say this is Tropic of Capricorn. Okay? The overhead sun is here at the equator on 21st of March. Right? On 21st of March, at equator, there is overhead sun, let's say in Maldives. In this position, there is no shadow day. Only over there, no other place is experiencing no shadow day. 22nd of March, it shifts north. है ना? 90-degree sunlight is shifting north, right? क्योंकि 21st of June तक यहाँ तक आ जाएगा 90-degree sunlight. Every subsequent day, it start to shift north, like this. From 21st of March, 30th of March, 15th of April, 30th of April, okay, 15th of May, 30th of May, 15th of June, 21st of June. By the time you come to 21st of June, the 90-degree sunlight is here. Okay, on 21st of June, overhead sun, no shadow day is observed at Tropic of Cancer. Next day, it starts to shift down again. It starts to shift down continuously, it starts to shift down. By 23rd of September, it is back at equator again. Overhead sun, 90-degree sunlight. Next day, it starts to shift down. Okay, it shifts down continuously, and by the time you come to 22nd of December, it is at Tropic of Capricorn. From Tropic of Capricorn, it again starts to shift north. Okay, every subsequent day, subsequent week, it is towards the north, and finally by 21st of March, it is at equator. Is it clear? The position of overhead sun or the no shadow day continuously shifts from one latitude to another latitude. From 21st of March at equator, it shifts towards the Tropic of Cancer on 21st of June. From 21st of June, it shifts towards the equator. Okay, by it shift towards the equator by 23rd of June. From 23rd June, 22nd December, it comes to Tropic of Capricorn. From Tropic of Capricorn to equator by 21st of March. On any particular time of the year, overhead sun is always observed between the Tropic of Capricorn and Tropic of Cancer. You will never observe overhead sun beyond the tropics. Is that right? 90-degree sunlight तो और कहीं पे भी नहीं होगा. Every place located between the tropics experiences 2 days of overhead sun. one while moving in this direction, another while moving in this direction. Any place located exactly on the tropics experience only one day of overhead sun. 21st of June on Tropic of Cancer, 22nd December on Tropic of Capricorn. And any place beyond that never experiences overhead sun. For example, beyond Bhopal in India, there is no overhead sun, there is no shadow day. No shadow day is observed up to Bhopal. And all the places to the south of them, they observe no shadow day twice. Once between 21st of March to 21st of June. Second between 21st of June to 23rd of September. Okay, हर place का अपना overhead sun या no shadow day होता है. If you clearly see, it is the Earth's orientation which is changing in this manner. Therefore, the sun appears to be shifting north or south. Okay, so जो sun का जो position है ना, it appears to be shifting north or south. It is not actually shifting. It is the sun, Earth's orientation which is changing. Therefore, this is called as the apparent movement of sun. The sun's position continuously appeared to be changing continuously from Tropic of Cancer to Tropic of Capricorn. There are two positions. One position from Capricorn to Cancer, the sun is shifting towards north. This is what is northward shift of sun, Uttarayan. The southward shift of sun, Dakshinayan. Okay, northward shift, southward shift. Northward shift starts from 22nd December. Okay, till 21st of June. Usually most of the, so auspicious celebrations, usually it happens during this. Why? Every day is brighter. Every day you are experiencing longer length of the day. From here, length of the day is decreasing. Every day is darker. Subsequently, every day is decreasing in daylight. Is that right? And if you observe this, you can very clearly see it in any place. Wherever you are located, you can very clearly see it by yourself. The sun's position continuously changing. For example, let's say you are located on the equator. On the equator, you are located, this is your position on the equator. Okay, and the date is 21st of March. The sun rises exactly here, at the east. Sun rises here at 6 o'clock. By 12 o'clock, the sun comes exactly here. Okay, by evening 6 o'clock, the sun sets over there. Fine? And 1 week later, you are at the equator only. Sun is not rising here. Sun is rising slightly towards the north. It has shifted north. You will see clearly the sun shifting towards the north. Sunrise is not happening exactly here. You keep a reference, कोई building का reference ले लो, यहाँ से sunrise नहीं होगा, यहाँ से होगा sunrise. At noon the sun is not here. At noon the sun is here. Okay, so at evening the sun is over there, not exactly at the west, slightly towards the north. You can very clearly observe this. You give a month further towards the north, further towards the north, further towards the north. On 21st of June, you will see the maximum position of the sun towards the north. From 21st, it will start to shift back again, down, down, down. On 23rd of September, it is back at the same point, same reference point. 1 week later, it shifts south. It is rising towards, slightly towards the south. Again south, again south, again south. There is a maximum southward position on 22nd of December. Again, it will start to shift north, 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 north. By 21st of March, it is back at the same position. You can observe this in any location. Equator का मैंने example दिया था और बाकी सारा example आप ले सकते हो. Okay, if at all you do that and you take a picture and make a, so a complete collage type बना के एक ही picture में लेके आ गया तो ऐसा दिखेगा आपको. Can very clearly see the sun's position shifting. Okay, somebody has done this. Okay, so you can see here, this is March. 21st of March, the sun is rising. After a month, sun is not rising here. Okay, same position, same type पे वो sun का picture click किया है in every month. Sun is not rising here. It has shifted here. Northward shift. After a month, it has shifted here. And this is the maximum shift on June 21st. उसके बाद में यहाँ पर southward shift हो गया. ये दोनों match हुआ है देखो. and then here ये दोनों match हुए, and then here by September equinox exactly same position. And 1 month later it had shifted down, down, down. December 22nd it is back at this position, the southernmost location. Then it has shifted slightly towards the north, towards the north, towards the north. This is the apparent movement of sun. Very, very important for many of the geographical concepts. Climatology में बहुत काम आते हैं. Apparent movement of the sun. That is all about seasons. Any doubts here? So let's see how much you have understood. Let's try to solve the PYQs. Seasons topic has the maximum number of questions. Okay, एक single topic से इतने maximum question कभी भी नहीं है, कोई भी geography topic में नहीं है. In the last 10 years, there are 4 times the questions have come, just on seasons only. What is the answer? Revolution of the earth on a tilted axis of rotation. Okay, that is the answer. What is the answer? 21st of June does not set below the horizon at Antarctic Circle. ये कब होगा? कब होगा? 22nd of December. Shines vertically overhead at noon. At equator. ये कब है? Equinox, 21st of March or 23rd of September. Shines vertically overhead at the Tropic of Capricorn. When is this? 22nd December. 21st of June. All the regions beyond Arctic Circle is polar day. Therefore, it does not set below the horizon. What do you mean by does not set below the horizon? Sun is always above the horizon. That is the meaning of 24 hours, right? You know how it is visible? Morning, sun is here above the horizon. Noon, sun is here above the horizon. Evening, sun is here above the horizon. And night, sun is here above the horizon. It takes a complete circle. Very beautiful phenomena. Okay, for 24 hours, the sun is always above the horizon. It never sets below the horizon. So this was from 2022. Longest day of the year is कब होगा? 21st of June. Longest day is 21st of June. Second half of the month of June. This is this year, 2024 का question. What is the answer? All of you agree D? B? Chalo. Sunlight of more than 12 hours. Will equator ever experience sunlight of more than 12 hours? It is always 12 hours throughout the year. Tropic of Cancer, sunlight of more than 12 hours. Summer in the north. Okay, that is 21st of June, definitely yes. Tropic of Capricorn, more than 12 hours of sunlight. That is summer in the southern hemisphere, 22nd of December. Arctic Circle, more than 12 hours of sunlight. पिछले वाले क्वेश्चन तो यही था. Okay, ऑप्शन देखो रिपीट हुए. ठीक है. So that is all about seasons. So let's continue after the break. Okay. So next topic, time zones. What is the idea of time zones? See, being Earth being spherical in shape, time is not same everywhere. Right? Sunlight will not fall in the same time everywhere. So for example, so imagine the camera to be the sun. Okay, so we'll start from here. So India, it is noon. So Africa, it is morning. So Japan is evening. USA is night. Can you see? Every different place on the earth has its own time because the sun's orientation is different. In the earlier days, this was not a problem because there was no real-time communication. There was no regular communication happening. Okay, so real-time, it was nowhere it was possible earlier days. And whatever the interaction, whatever the activity which was happening, it was limited to that area only. Okay, so purana time mein. So there was no necessity to know what is the time in another place. इंडिया में बैठ के यूएसए का टाइम अभी क्या है, अफ्रीका का टाइम क्या है, तो जापान का टाइम क्या है, ये सोचने का ज़रूरी नहीं था. But with globalization, with communication development, okay, so with technological advancement, we wanted to know right now, यहाँ पर बैठ के जापान में अभी टाइम क्या है. Obviously, time is different in every latitude, right? Every longitude. So we wanted to know that. We wanted to have some method of calculating time in different places. And time remained the same for the entire longitude. ये तो clear है ना? अगर ये इंडिया का बात कर रहे हो, अगर इंडिया में नून है, Kazakhstan is also noon. Okay, same time. The sun is overhead. Overhead नहीं है तो at least maximum angle. Okay, so here in Russia also it is the same. Okay, Kazakhstan ले लो, Russia ले लो, या Indian Ocean ले लो, यहाँ पर. The entire longitude, the time remain the same. Is that right? Go to any longitude, the time is always same. Latitude में time changes, of course. Within the same latitude, time changes. But within the same longitude, the time is always same. To have this broad understanding of the time at different locations, we have divided the entire world into 24 time zones. The entire world is divided into 24 time zones because the total of 24 hours. Right? Because a rough idea देखो, यहाँ पर इंडिया में आप देख रहे हो, this is India. और यहाँ पर इंडिया में देख रहे हो, USA is exactly opposite. If this is noon here, what is the time here? Midnight. Simple logic. If this is midnight, this is morning, this is evening. Okay, so if you change the longitude by 90 degree, you are changing the time by 6 hours. If you change the longitude by 180 degree, you change the time by 12 hours. Right? You change the longitude by 180 degree, time changes by 12 hours. Overall, the entire world is divided into 24 time zones like this. The entire world is divided into 24 time zones. In each zone, time is assumed to be the same. It is assumed to be uniform. Okay, within the entire zone. Technically, gaya to time changes with every longitude. Time changes with every longitude. If at all, this is the position of overhead sun. Okay, maximum angle of sun is here. तो तब भी 12 o'clock होगा यहाँ पर. इसके एक longitude पीछे 12 o'clock नहीं है, एक longitude आगे भी 12 o'clock नहीं है. Exactly at one particular longitude only there is 12 o'clock. You go one longitude behind, what will be the time right now? Right now, if it is 12 o'clock here, one longitude behind, what will be the time? 1 degree changes causes 4 minutes of time change. 4 minutes, because 360 degrees 24 hours. 360 degrees 24 hours. 1 degree is 4 minutes. 4 minutes. So right now, if it is here 12 p.m. in the longitude 1 degree behind, the time is 12:04. It is 12:04. Why? Because 4 minute पहले यहाँ पर 12 o'clock था. अभी यहाँ पर 12 o'clock हुआ है ना? So let's take the longitudes. Okay, so this is, let's say this is 80 degree, this is 81 degree, this is 79 degree. ठीक है? Here the time is 12 p.m. Right now here the time is 12 p.m. Before the 90 degree sunlight was falling here, earlier it was falling here because the sun is moving in this direction. Sun moves in this direction, right? 4 मिनट पहले यहाँ पर था, अभी यहाँ पर आ गया, 4 मिनट के बाद में यहाँ पर होगा सन. तो जब यहाँ पर आए, this is what is 12 p.m. Right now this is 12 p.m. 4 मिनट पहले यहाँ पर 12 p.m. था. अभी टाइम 12:04. 4 मिनट पहले 12 o'clock, अभी 12:04 होगा. यहाँ से 4 मिनट के बाद में यहाँ पर 12 o'clock होगा. Right now the time is 11:56. That is how. Technically, if you go, the local time is the time based on the sun. The local time changes by 4 minutes for every 1 degree. Every 1 degree, the local time changes by 4 minutes. But this is not perceivable. You will not be able to perceive this. It becomes practically too difficult to implement this. एक डिग्री चेंज करने से तो फिर दिल्ली में, सोनीपत में, मेरठ में अलग अलग टाइम हो जाएगा. It's not practical. So what we did, we'll keep the entire area to be totally uniform up to 15 degrees. 15 degrees तक टाइम को हम यूनिफॉर्म रख लेंगे as a assumption. Local time based on the sun's position always vary, but for the sake of simplicity, up to 15 degree, let's keep the time to be uniform. In the longitudinal distance of 15 degree, time changes by 1 hour. यहाँ पर और यहाँ पर जो टाइम डिफरेंस होगा 1 hour, 15 into 4. Okay, so 1 hour तक हम चेंज यूनिफॉर्म ही रखेंगे. For this entire 15 degrees, we'll keep the time to be uniform. Once you change from here to here, again we'll shift the time by 1 hour. So that is how we have divided the entire world into 15, 15, 15 like this, each time zone. Each time zone accounts for 15 degrees, with each time zone of 15 degree accounting for 1 hour of time. पूरा वर्ल्ड को ऐसे 15, 15, 15, 15 डिवाइड कर दिया. इफ यू डिवाइड लाइक दिस, फ्रॉम ग्रीनविच एज अ रेफरेंस, टुवर्ड्स द वेस्ट देयर आर 12 टाइम जोन, टुवर्ड्स द ईस्ट देयर आर 12 टाइम जोन्स. Towards the east there are 12 time zones, towards the west there are 12 time zones. Now it is very easy to calculate. You just have to know where is your friend located, where is the other person located, in which time zone he is located. Let's say you have a business in India and your business partners are located in one in Japan, another one in USA. ठीक है, ऐसे मान लो. So whenever you are having the meeting, you want to know before the meeting only what is the time over there. Calculate करना है ना, तो टाइम तो सिंक्रोनाइज करके ही करना पड़ेगा ना. इफ यू आर लोकेटेड हियर, योर फ्रेंड इन जापान इज लोकेटेड बाय 1, 2, 3, 4. ओके, 4th टाइम जोन में है. 4 hours of difference between you and your friend. 4 hours of difference between you and USA. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A person located in USA, there is 12 time zone ahead. 12 time zone difference is there, so 12 hours of difference. Very easy to calculate. To calculate the time across the world, you just have to know what is the time zone difference. Each time zone difference, 1 hour, you have to add or subtract. In which case you will add. If you are located here, your friend is located towards your east. East gain addition. A person who is located towards your east, he is always ahead in time. If he is ahead by 4, if the time zone difference between you and that friend is 4 time zone, he is ahead of your time by 4 hours. If it is 12 o'clock here, there it is 4 p.m. 4 hours ahead. Towards the west, time decreases. West lose subtraction. If another person is there here, okay, 6 hours of behind, that means the time difference between you and him is 6 hours. If it is 12 o'clock here, there it is 6 a.m. 12 p.m., 6 a.m. is behind. Very easy to calculate now. अभी इस मोमेंट में इंडिया में बैठ के इंडिया में ये टाइम हो रहा है, यूएसए में क्या टाइम हो रहा है, जापान में क्या टाइम हो रहा है, ओके, सो साउथ अफ्रीका में क्या टाइम हो रहा है, ऑस्ट्रेलिया में क्या टाइम हो रहा है, कहीं पे भी जाओ आप पता कर सकते हो. जस्ट हैव टू नो वन डेटा. व्हाट इज द डेटा? व्हाट इज द टाइम जोन डिफरेंस बिटवीन यू एंड दैट पर्सन? यू नो योर टाइम जोन, उनका टाइम जोन पता कर लो बस. हमेशा उसको ऐड कर लो या सबट्रैक्ट कर लो, जो भी है डिफरेंस. दैट इज द आइडिया ऑफ टाइम जोन्स. ठीक है? इट इज एन अटेम्प्ट टू मेक थिंग्स easier and simpler. But the problem is the countries are not divided according to the time zone. You cannot make this very very strict. Okay, from 0 degree Greenwich meridian 15 होते ही एक टाइम जोन शिफ्ट कर लेंगे तो वहाँ पर जो भी रीजन आएगा वो उसको यही फॉलो करना है, ऐसा बनाना बहुत मुश्किल है. Okay, so for example, okay, this is the Greenwich meridian. यहाँ से एक टाइम जोन शिफ्ट करते ही इट पासेस थ्रू मल्टीपल कंट्रीज, मेनी कंट्रीज ओवरलैप लाइक दिस. यहाँ से ओवरलैप हो जाएगा, यहाँ से ओवरलैप हो जाएगा. Just because it falls in half of the country falls in this time zone, half the country falls in other time zone. You cannot say इनका ये टाइम होगा, उनका वो टाइम होगा. ये इतना rigid नहीं बना सकते हो. Instead, the countries are given the freedom to choose their own central longitude. Every country will have their own central longitude, and उस longitude में जो टाइम होगा पूरा country का टाइम वही हो जाएगा. And that central longitude is pegged according to Greenwich. ग्रीनविच में कितना दूर में है वो सेंट्रल लॉन्गिट्यूड, वो बता दो, वो हो जाएगा स्टैंडर्ड टाइम ऑफ दैट पर्टिकुलर कंट्री. फॉर एग्जांपल इंडिया एक्सटेंड्स वेरी वाइडली. देखो ये पूरा रीजन में कवर होता है फ्रॉम हियर टू हियर. टेक्निकली देखो तो 2 टाइम जोन के ऊपर ओवरलैप हो जाएगा. फॉर द सेक ऑफ सिंप्लिसिटी इंडिया चोज द सेंट्रल लॉन्गिट्यूड. द सेंट्रल लॉन्गिट्यूड ऑफ इंडिया इज 82.5 डिग्री ईस्ट. Okay, 82.5 degrees east is the central longitude between the easternmost and westernmost part. Central में जो चलता है ना, that is 82.5 degree east. 82.5 degree east means from Greenwich it is located at a distance of 5 hours 30 minutes. 5 into 15, 75. 7.5 is 30 minutes. Okay, so to the world we have declared India follows 82.5 degree east longitude or GMT plus 5.5. सबको पता है GMT plus 5.5? In sitting in any corner of the world, you can calculate the time of India. So this longitude, whatever the time in this longitude is the time all over India. That is the meaning of Indian Standard Time, IST. 82.5 degree east longitude passes through Mirzapur in Uttar Pradesh. So मिर्जापुर में जो लोकल टाइम होगा पूरा इंडिया का टाइम वही होगा. Only in Mirzapur, the sun time matches with the clock. Okay? मिर्जापुर का टाइम है पूरा इंडिया का टाइम. मिर्जापुर में इनफैक्ट देयर इज आल्सो एक क्लॉक टावर. जहां से ये लॉन्गिट्यूड पास होता है ना, वहां पर एक क्लॉक टावर बनाया इन लोगों ने. कोई है मिर्जापुर से? So like this every country will choose the central longitude जो जिनको चाहिए, फिर उनको कैलकुलेट कर लेंगे GMT से कितना दूर है. Okay, for example, if you go to Myanmar, they're like 6 hours from GMT. Okay, so फिर थोड़ा सा उस साइड में जाओ, 6 hours 15 minutes होगा, 6 hours 30 minutes होगा. Usually they keep a time of 15 minutes for the sake of, you know, so standardization. 15 degree 15 minutes में चेंज करते हैं. So this is the idea of time zone. Okay? A country with greater latitudinal extent or greater longitudinal extent. Among these two, there are 2 countries. One with the greater latitudinal extent, another with the greater longitudinal extent. Which one follows multiple time zones? Longitudinal extent. What do you mean by longitudinal extent? The difference between the easternmost and westernmost longitude is longitudinal extent. The difference between the northern and southernmost latitude is latitudinal extent. If a country has greater latitudinal extent with least longitudinal extent, उससे कोई फायदा नहीं है. For example, Chile. It has a very high latitudinal extent. बट उससे कोई फायदा नहीं है, हमें देखना है लॉन्गिट्यूड. लॉन्गिट्यूडनल एक्सटेंट देखो, देयर इज वन ऑफ द लीस्ट. Okay, so it follows only a single time zone. Russia, from the easternmost to westernmost point, it is highly elongated. It has a very great longitudinal extent. Here you cannot follow a single time zone. If you follow single time zone, what happens? There's too much of mismatch. यहाँ पर जो एक्चुअल टाइम है वो पूरा क्लॉक पूरा कंट्री में, पूरा रशिया में एक ही टाइम हो जाएगा. यहाँ पर सन राइज सन नून है, यहाँ पर ऑलरेडी सनसेट हो गया, फिर भी यहाँ पर 12 बजे दिखा रहा है. इट्स नॉट पॉसिबल, राइट? इट्स नॉट फिजिबल. सो दे आर बाउंड टू फॉलो मल्टीपल टाइम जोन्स. They follow multiple time zones. A country with greater longitudinal extent, they follow multiple time zones. A smaller one tries to adjust and follow single time zone, because single is always better. Less confusion. Which country has the highest number of time zones? France. How come France? Because of overseas territory. Even though this is France, France has islands in many different parts of the world, many locations. Everywhere they follow their own time zone, right? Together it follows a total of 12 time zones. France follows 12 time zones, USA follows 11 time zones, Russia follows 11 time zones. India follows only one time zone. But still, even in India also there is a demand to follow second time zone. Demand to hai. Because the difference between the easternmost and westernmost longitude in India is nearly 30 degrees. 30 degrees means 2 hours. Okay, if you go by local time में गया, standard time छोड़ दो, local time पे गया, the time in easternmost part of Arunachal. Okay, what is the easternmost town of Arunachal? Kibitu. Kibitu is the easternmost point of India. The westernmost point of India is Sar Creek. Sar Creek is the westernmost point of India. Between these 2 points, there will be a time difference by local time. If you go by the sun, the time difference will be 2 hours. 30 degrees are 2 hours. Right? However, for the sake of standardization, both of them will follow the same time. Watch में same ही time दिखाएगा. वो कौन सा time होगा? मिर्जापुर का time होगा. This creates issue. What kind of issue? Let's try to see. IST, Indian Standard Time. Everywhere it is same, and that is the time at Mirzapur. Let's say the local time at Mirzapur is 6 a.m. IST is 6 a.m. Here IST is 6 a.m. Here IST is 6 a.m. Is that right? Everywhere the time is same. Mirzapur में जो time होगा पूरा इंडिया में all over same time होगा. But what about the local time here? यहाँ पर local time क्या है? If the time at Mirzapur is 6 a.m. towards the east, 15 degrees, the time is added. The time, local time here is 7 a.m. Towards the west, the time is subtracted. The time is 5 a.m. Right? 7 a.m. ठीक है लोकल टाइम. देखो अभी यहाँ पर सनराइज हो रहा है, 1 घंटे के पहले यहाँ पर सनराइज हुआ था ना, 1 घंटे के पहले सनराइज हुआ है, अभी टाइम क्या होगा? 7 a.m. ठीक है. The local time according to the sun is 7 a.m. but the clock is showing 6 a.m. मतलब क्लॉक तो 1 घंटे पीछे है. The local time according to the sun is 5 a.m. but the clock is showing 6 a.m. क्लॉक में 1 घंटे आगे. ओके, सो किसके लिए नुकसान है? आगे करने से फायदा होता है, पीछे करने से नुकसान होता है. Because most of the agriculture activities, most of the rural areas, many of the field work, they all depend upon the sun. thinking you are getting up at 6 o'clock, 6 o'clock उठ गया, already sunrise हो गया. Okay, so यहाँ पर 6 o'clock sunrise हो रहा है. Okay, go by the clock time. Clock time is 6 a.m., clock time is 6 a.m., clock time is 6 a.m. But the sunrise is happening here. There the sunrise would have happened 1 hour early. Sunrise there happens at 5 a.m. Here the sunrise happens at 7 a.m. clock के हिसाब से. Okay, sunrise वहाँ पर clock के हिसाब से 5 a.m. हो गया है. लोग उठेंगे 6 बजे. Okay, so ये देखते हैं तो 1 घंटे चला गया. You have lost 1 hour. Because agriculture work usually it happens earlier in the morning. People as soon as they get up, they go to the agriculture field. Okay, they start to do the work. Okay, because before the sun comes to the noon, they have to complete major part of the work. Right? So then you can have food, take a nap, and then when sun starts to go slightly lower, then you start the work again. You will do the work till the sun sets. 1 घंटे सुबह चला गया. You are already late. You will go to the field, you will start to work. 5 o'clock sunset हो गया. है ना, 5 o'clock सनराइज हुआ तो 5 o'clock सनसेट हो जाएगा ना. 1 घंटे शाम में चला गया. दे हैव लॉस्ट 2 hours. यहाँ पर 6 बजे उठ के देखता हूँ अभी सनराइज भी नहीं हुआ है. आराम से रेडी हो जाओ, खाना वाना खा लो, वेट करो सनराइज के लिए, इमीडिएटली आराम से जाओ. इट इज़ गुड. एंड इवनिंग सनसेट हैपन्स एट 7 o'clock, यू विल गेट 1 hour एक्स्ट्रा टाइम. दिस इज बेटर. यू मे आस्क उनको जल्दी उठने दो 5 o'clock. क्यों उठना है भाई, जल्दी क्यों उठना है? ऑल ओवर इंडिया सेम टाइम चलता है ना. All over India, bank time is same, government office time is same. Okay, so TV का जो serial चलता है उसका भी time same. 9 o'clock prime time news is time is same. That is most entertaining. Everywhere they are following the same time, and you are asking them to sleep early and get up early. Why would they do that? It creates issue in Northeast. In Northeast, the sun rises early, sun sets early. On daily basis, there is a loss of sun time. It's a loss. Therefore, there is a demand. Let's create a second time zone at this entry point. Siliguri corridor होके Assam enter करते हैं, second time zone शुरू कर लेते हैं. This is a recommendation. Okay, so not just by the local people, even the government committee has recommended. NPL, National Physical Laboratory, has recommended this because this is a practical problem over there. Okay, so imagine daily basis productivity is low. Usually the tendency is that after sunset nobody would want to go out. Usually तो होता है rural areas में तो यही है, nobody goes out. Okay, so sunset हो गया, चलो सो जाते हैं, जो भी काम है कल कर लेते हैं. Economic productivity decreases, economic activity decreases. There is a loss. So बोल रहे कि यहाँ पर दूसरी time zone बना देते. Okay, so बाकी सारा rest of India let's follow one time zone. Okay, IST1, IST2 ऐसे. This is GMT plus 5.5. This is GMT plus 6.5 ऐसे. Okay, there is a recommendation, but all the governments successively have rejected this proposal. Okay. One of the important argument given is that it creates a lot of confusion. There's too much of population in India. दूसरी countries में population कम होते हैं, follow करना easy होगा. India में follow करना मुश्किल होता है ऐसे. Okay, but this was not the case earlier. Earlier India followed 3 time zones. India had earlier followed 3 time zones. Okay, this is not something new for India. During the British time till 1906, India followed 3 time zones. Yes. Okay, so Kolkata ke around Kolkata time, in this central area, Madras time, here the Bombay time, based on 3 presidencies. We followed 3 time zones. Because British का तो आदत था ना, so they used to follow multiple time zones everywhere. They had follows, they had implemented here. Because the more closer you are to the sun, the better it is. Sun के लिए जितना पास में रहोगे, sun cycle के लिए जितना पास में रहोगे, the better it is. So gradually they realized that there is no need for 3 time zones as such. इतना भी ज़्यादा नहीं है, तो बोल के so single बना दिया. That was done in 1906. Indian Standard Time was adopted in 1906. But even after that, in Bombay Presidency and Calcutta Presidency, only within the city they used to follow local time. Okay, within the city they used to follow local time. Bombay time, Calcutta time was there. And that was abandoned in 1955. From 1955 we are following single time. However, in tea gardens of Assam, there is a local time which they follow. That is what is Chai Bagan time. Tea garden time. बिकॉज दीज पीपल लिव इन साइड द टी गार्डन ओनली, दे रेयरली कम आउट, उनके लिए ज़्यादा कुछ इशू नहीं है. Okay, they have set their own local time. This is not official, remember. This is unofficial. They follow it locally. That is still continued. Rest everything is abandoned. We have only Indian Standard Time, IST. So this argument doesn't hold true that India के लिए नया हो जाएगा, लोगों के लिए मुश्किल होगा. We had followed this earlier also. But there are certain genuine issues. What are the issues? Synchronization of economy. Same banking time, stock exchange, okay, trade activities, industrial activities, everything there will always be issue if you bring two time zones. Transportation, railways, flight, airways, take-off landing time, there is always confusion. Railways इतने zone है, इतने सारे बीच में चलना है, आगे जाना है, पीछे जाना है, okay, it creates confusion. Okay, so transportation, it creates confusion. Administrative. ओके, गवर्नमेंट ऑफिस का जो टाइम होता है वो इशू होता है. ऑलरेडी गवर्नमेंट में इतना स्लो चलेगा, फिर एक और बहाना मिल जाएगा, वहाँ पर ऑफिस नहीं खुला है, रुक जाओ, वहाँ पर ऑफिस बंद हो जाएगा, कल आ जाना. ओके, सो दैट क्रिएट्स एडमिनिस्ट्रेटिव इनकन्वीनियंस. मोस्ट इंपॉर्टेंटली एजुकेशन, स्कूल्स, कॉलेजेस, टाइमिंग अलग अलग हो जाएगा. ओके, सम ऑफ थिंग्स यू हैव टू सिंक्रोनाइज. फॉर एग्जांपल ऑल ओवर इंडिया एग्जाम, ओके, यूपीएससी का एग्जाम मान लो, ऑल ओवर इंडिया सेम टाइम में होना चाहिए ना. अगर सेम टाइम में कंडक्ट करना है, उनके लिए अलग टाइम बताना है, इनके लिए अलग टाइम बताना है, तभी सेम टाइम में शुरू होगा. देयर टाइम जोन इज डिफरेंट, हियर टाइम जोन इज डिफरेंट. और यू मेंशन द सेम टाइम इन द हॉल टिकट, वहाँ पर जल्दी शुरू हो जाएगा, फिर पेपर लीक हो जाएगा. Okay, so synchronization is the problem. So therefore, and not only that, even the communication, border management, कि you have to make uniform communication, uniform synchronization होना चाहिए. So to avoid this, बोल रहे हैं कि चलो adjust कर लो. एडजस्ट तो वहाँ पर हो रहे हैं, हम तो कुछ भी नहीं कर रहे हैं. इनफैक्ट यहाँ पर और बेटर है. ओके, सो 6 बजे उठने के बाद में सन नहीं आए तो आराम से थोड़ा और आधा घंटा सो जाओ. ओके, आराम से रेडी हो जाओ. ओके, सो व्हेन द सन कम्स, एक्टिविटी स्टार्ट्स. सनसेट इज ऑल्सो हैपनिंग लेट. इट्स गुड. दैट इज द आइडिया ऑफ मल्टीपल टाइम जोन्स. What about international date line? वो क्या होता है? Ideal. Ideal is an imaginary line which is used to demarcate the beginning of new date. Okay, जैसे टाइम जोन हमने इमेजिन किया है, ऑल ओवर द अर्थ वी हैव इमेजिन वन लाइन जहां से डेट शुरू होगा. Because we cannot use this practically. Globe cannot be used practically. Practically, map ही होगा. Okay? When you put the globe in the form of map, that is the beginning of the world. This is the end of the world. When you are traveling from that point to this point, आपको time लग जाएगा 24 hours. Okay? So leave about the travel time. Time difference कितना होगा from that point to this point? 24 hours. है ना? But technically if you see that point is same as this point. ये तो पीछे से connected है ना? There is a time difference of 24 hours. अगर morning 6 o'clock, this is morning 6 o'clock. Afternoon 12 o'clock, this is also afternoon 12 o'clock. Time same ही लगता है. But यहाँ से यहाँ पर आने के लिए 24 hours का overall difference है in terms of time zones. 24 hours is one day. That is morning 6 o'clock 25 December. This is morning 6 o'clock 24 December. है ना? There is a difference of 24 hours. तो जहाँ से भी हम शुरुआत करेंगे वहाँ से डेट का कैलकुलेशन शुरू होगा. Okay, that you can keep it anywhere. शुरुआत तो कहीं से भी करो. Okay, so you cut anywhere and you make the world map. हमने यहाँ से इसलिए कट किया है. There is not much of land here. Okay, that is why the beginning of the world map is always usually from the Pacific Ocean. ज़्यादा लैंड नहीं है ना. इसको ऐसे ओपन किया, इसको ऐसे ओपन किया, ठीक है. And that is where international date line also passes. If you keep the international date line somewhere here, what happens? यहाँ से शुरू हो जाएगा, फिर डेट मैप के हिसाब से यहाँ से यहाँ तक आने में आपको 24 आवर्स डेट का डिफरेंस आ जाएगा ना. दिस इज वन डे अहेड, दिस वन डे बिहाइंड. सेम कंट्री के अंदर तो ये मुश्किल हो जाएगा. जितना लैंड कम हो उतना अच्छा है. And there also there is some intersection of the land area. Can you see some part of the Siberia crosses on the other side? 180 degree को cross करते उस side में चला जाता है. Some part of Alaska comes on this side. If you keep it completely straight, so that part will follow a different date and this part follows another different date. So therefore, they have made it little bit of zigzag. Here also there is some zigzag because all these group of islands belong to the same Pacific Islands. Micronesia, Melanesia, Polynesia. They want to be on one side. If you keep them separate, date changes. Time same ही रहेगा, date अलग हो जाएगा, फिर confusing है. Whenever the places are separated by international date line, the date is totally different. Okay, so let me show practically कैसे होता है. Let's take 3 locations. Okay, this is UK, this is Siberia, this is Alaska. Okay, let's say UK, the time is 8 p.m. 12 hours of difference, 180 degree. What is the time in Siberia? This is 8 p.m. 12 hours towards the east, add. Towards the east, add 12 hours, you are at 8 a.m. रात में 8 o'clock, so next 12 hours add कर लो, 8 a.m. If this is 25 December, this will be 26 December. You have added 12 hours, right? You have gone into the next date. है ना? This is 8 p.m. यहाँ पर अलास्का में टाइम क्या होगा? 12 hours का डिफरेंस है. बट ये पीछे है. From 8 p.m. subtract 12 hours. 8 a.m. But on the same day. Is that right? Now UK को छोड़ दो, इन दोनों को कंपेयर करो. Alaska and Siberia. Siberia 8 a.m., Alaska 8 a.m., Siberia 26 December, Alaska 25 December, because both are separated by international date line. है ना? तो टाइम सेम ही लगता है बट डेट अलग हो गया क्योंकि दोनों को दूसरी एंड माना जाता है. हमारा डेट वहां से शुरू होता है, वहां से यहां पर आने में एक दिन तो लगेगा ना. To see 26 December 8 a.m. you have to wait for 24 hours here. After 24 hours, this will become 26 December 8 a.m. Is that right? There is a time difference of 24 hours. Even though their time is same, their date is different because they are separated by international date line. Whenever two places are separated by international date line, the date completely becomes different. What happens if somebody crosses international date line? Let's say there are 2 islands. This is island 1, island 2. This is A, this is B. ठीक है? Let's say you are working on this island and your friend is here. Okay, आप इस साइड में हो, आपका फ्रेंड यहाँ पर है, बीच में इंटरनेशनल डेट लाइन है. ठीक है? Let's say the date here is 24 December. ठीक है? And the time is 8 p.m. Okay, this is the date and time in your island. So for you, next day is Christmas. Imagine in your office they had not given holiday on 24 December. You worked for the entire day. You are totally tired. You have come home. मान लो आपके घर में कोई नहीं है तो आप अकेले हो. You decide to visit your friend. चलो वहाँ पर जाके दोनों मिलके क्रिसमस मनाते हैं ऐसे बोल के. What you will do? You will cross the international date line in this direction. You will take out a boat. आइलैंड है, बोट रहेगा तो बोट लेके इस साइड में आ गया तो आपके दोस्त के घर में जाके देखते हो यहाँ पर तो 8 p.m. है ऑब्वियसली, बट 25 दिसंबर. यहाँ पर आके देखते हो यहाँ पर क्रिसमस खत्म हो गया. By crossing the international date line from east to west, remember from east to west, For international dateline, this is east. For international dateline, this is west. Please don't think from India. इंडिया यहाँ पर है, इंटरनेशनल डेटलाइन यहाँ पर है. आप ये मत सोचो कि आपके लिए ये ईस्ट है, आपके लिए वो वेस्ट है. तो यहाँ से ऐसे घूम के आओगे ना यूएसए की तरफ से लगेगा. सो प्लीज डोंट थिंक फ्रॉम इंडिया. स्टैंड एट द इंटरनेशनल डेटलाइन एंड देन सी दिस इज ईस्ट, दिस इज वेस्ट. यू आर क्रॉसिंग इंटरनेशनल डेटलाइन फ्रॉम ईस्ट टू वेस्ट, यू विल लूज ए डे. यहाँ से यहाँ पर आके देखते हो तो यहाँ पर क्रिसमस खत्म ही हो गया ना. आप क्रिसमस शुरू भी नहीं हुआ था. यहाँ पर 25 दिसंबर 8 PM क्रिसमस इज गॉन. मान लो उल्टा करते हैं. लेट्स से यू आर ऑन दिस आइलैंड, द डेट इज 25 दिसंबर एंड 8 PM. यू हैड सेलिब्रेटेड योर क्रिसमस, पूरा अच्छे से पार्टी वार्टी कर लिया सबसे मिलके. फिर दोस्त का याद आया, ओके तो बेचारा अकेले है उधर, चलो जाके मिल के आ जाते बिफोर क्रिसमस एंड्स. Okay, you will take out your boat and you will travel on this direction. You will come and you will go and see his place. The Christmas is just beginning. You have one more Christmas. There is a gain of a day. Okay, so आपका पूरा यहाँ पर क्रिसमस खत्म करके आए हो, अभी 24 hours और है आपके पास, एक और पूरा क्रिसमस मिलेगा. Right? When you cross international dateline from west to east, you will gain a day. When you cross it from east to west, you will lose a day. मान लो आपके पास ऐसे कुछ स्पेशल डे है. Okay, let's say there is some memorable day, you want to remember it, you want to celebrate it. तो पहले यहाँ पर चले जाओ, यहाँ पर सेलिब्रेट करो, फिर इस साइड में जाओ, फिर इस साइड में सेलिब्रेट करो. Okay, ऐसे हो सकता है साइबेरिया एंड अलास्का के बीच में. There are actually 2 islands are there exactly near to Bering Strait. Okay, where international dateline passes. दोनों island they are separated by 24 hours. टाइम सेम ही है. अगर ऐसे कुछ दिन है कि बहुत ख़राब दिन था, यू डोंट वांट टू रिमेंबर दैट, तो यहाँ से यहाँ पर आ जाओ तो ख़त्म हो गया फटाफट. ठीक है, दैट इज इंटरनेशनल डेटलाइन. व्हाट अबाउट DST? हैव यू हर्ड ऑफ DST, डेलाइट सेविंग टाइम? द कॉन्सेप्ट ऑफ DST, हैव यू हर्ड? It's basically an idea to save time. Okay, so I already told you, if you forward the clock, you will save time. कि ये हम भी करते हैं ना. So घर पे जो होता है मेन क्लॉक, उसको यूजुअली आगे रखते हैं. 1 घंटे, मतलब 1 घंटे तो नहीं करते, 10 मिनट 15 मिनट आगे रख देते हैं. सो दैट इवन इफ यू आर लेट, आप तो क्लॉक देख के रेडी हो रहे हो, तो लेट हुआ तो भी तो टाइम पे पहुंच जाओगे. दिस इज द आइडिया, राइट? इन सम प्लेसेस, most of the temperate countries, during the summer, the length of the day is longer. Length of the day is longer, है ना? So let's say instead of 12 hours, you are getting 14 hours. 14 hours of day आपके पास है summer में. If you plan your day accordingly, you will save a lot of time, lot of energy. You can make your day more productive. कैसे बताता हूँ देखो. Let's say you are a person who gets up at 6 o'clock. नॉर्मली 6 o'clock उठते हो, 10 बजे ऑफिस जाते हो. Okay, let's say that you go to office at 10 o'clock and come back from the office at 6 o'clock. ठीक है, and you sleep off at 10 o'clock. This is your routine on a normal day. So during the summer, the sunrise is happening at 5 o'clock. Sunset is happening at 7 o'clock. If I say आप थोड़ा सा 1 घंटे जल्दी उठ जाओ, rather than getting up at 6, get up at 5. Rather than going to office at 10 o'clock, go to office at 9 o'clock. 5 बजे वापस आ जाओ. 5 से 7 के बीच में जो टाइम है ना, 1-2 घंटे का आपको एक्स्ट्रा टाइम मिल जाएगा. You can spend it in the sunlight. I already told you, sunlight में जो होगा वो प्रोडक्टिव होगा. People are more active. They tend to go out. जो भी काम है अच्छे से करना है तो, या बाहर जाना है, घूमो, जो भी करो, you spend your time with the family, everything. When the sunset happens, the mood changes. It happens. ये रूरल एरिया ले लो या कहीं पे भी ले लो, it happens. So if you get up 1 hour early in the evening, you are saving 2 hours. Is that right? You sleep off rather than 10 o'clock, sleep off at 9 o'clock, no issues. Since you are getting up at 5 o'clock, you sleep at 9 o'clock, it's okay. If I say this, nobody will follow. क्यों उठना है सर? तो रहने दो, 6 बजे उठेंगे, क्या हो जाएगा? Rather than that, I say, okay, so you forward your clock. You get up at 6 o'clock only, you forward your clock by 1 hour. ओके सो या मैंने बिना बोल के आपका क्लॉक फॉरवर्ड कर दिया. Okay, so you are thinking that you are getting about 6 o'clock only, but actual time is 5 o'clock. You get up at 5 o'clock. You are thinking your watch is showing you it is 10 o'clock. You are going to office at 10 o'clock, but you are actually going to office at 9 o'clock. You will come back to the home at 6 o'clock, but you are actually coming at 5 o'clock. 5 to 7 आपका sunlight तो बचता है. Now you have 2 hours of productive time. You'll spend not only productively, you will also reduce the electricity. Okay, so पहले ऑफिस से आते आते सनसेट हो गया था, 6 बजे सनसेट हो गया था ना. So 6 to 10 you had spent 4 hours in darkness or you use electricity. So अभी आने के बाद में 2 घंटे सनलाइट होगा, 2 घंटे का टाइम you will spend it in the electricity. Imagine at the national level how much of electricity can be saved. At national level the productivity increases, economic activity, economic productivity increases. With this idea they implemented this, because even the same time earlier days also same thing used to happen. If anyone is saying jaldi उठ जाओ, nobody used to follow that. बोला कि ठीक है अपने टाइम पे उठ जाओ, क्लॉक आगे कर दो. Okay, so entire country used to follow this. पूरा के पूरा everyone in the entire country they used to fix a day. समर के पहले इस टाइम में ये इस दिन में होगा तो 1 घंटे आगे करना है. जैसे जैसे समर खत्म हो गया फिर वापस लेके आना. यू हैव टू ब्रिंग इट बैक बिकॉज यू डोंट वांट टू गेट अप अर्ली इन द विंटर आल्सो, राइट. तो विंटर में क्या करोगे, सनराइज ही नहीं होगा. इट्स ए प्रैक्टिस ऑफ शिफ्टिंग टाइम बाय 1 hour बिफोर द बिगिनिंग ऑफ समर एंड शिफ्टिंग इट बैक बाय द एंड ऑफ समर, सो दैट देयर इज ए सेविंग ऑफ डे लाइट. दिस इज कॉल्ड एज डे लाइट सेविंग टाइम, DST. It is not practiced in India, it is practiced only in temperate countries. Okay, tropical countries में इसका use नहीं है because the length of the day has to be longer during the summer. Okay, we observe that only in the higher latitude the longer length of the day is there during the summer. Okay, and for the sake of simplicity they follow only 1 hour of shifting. ऊपर जाते जाते और ज़्यादा लंबा टाइम मिलेगा, ज़्यादा शिफ्ट करेंगे ये और ज़्यादा confusion हो जाता है ना. So they shift only 1 hour. Either DST or no DST. Okay, तो यही दो चीज़ है. Either a country follows DST or they don't follow DST. Okay, that is why the time between London and India, normally it is 5.5 hours. During the summer it is 4.5 hours. They follow DST. 1 घंटे आगे कर देते हैं. ठीक है. Milankovitch cycles. What are these Milankovitch cycles? We have assumed the earth to be completely uniform in its motion. The rotation, revolution जो भी हो रहा है ना, we have assumed it to be completely uniform. But it doesn't happen like that. ये ऐसे नहीं होगा. It is not 100% uniform. There is a cyclical changes which happens over a long period of time. There are 3 cycles. First one, the changes in the Earth's eccentricity. What do you mean by eccentricity? Eccentricity is the amount of distortion which is present in the orbital shape. Okay, if the orbital shape is perfect circle, there is no distortion at all. A circle has 0 eccentricity. You bring eccentricity, it starts to become elliptical. और ज़्यादा eccentricity और ज़्यादा elliptical. जितना eccentricity लेके आओगे उतना ज़्यादा elliptical होते जाएगा. Eccentricity is basically mean the amount of distortion. Greater the eccentricity, greater the distortion. We know the Earth's orbit is elliptical, but the amount of eccentricity in the elliptical orbit is not fixed. Over a long period of time, Earth's orbit becomes slightly higher eccentric and then comes back to the least eccentric and then again goes to become higher eccentric. Like this, it continuously changing, like a band, rubber band, ऐसे. It becomes highly eccentric and then least eccentric and then again highly eccentric. Like this, it continuously changes. The eccentricity of Earth's orbit goes in a cycles. During its peak time, it is highly eccentric. Let's say ऐसे. During the least eccentricity, it comes down to be like this. Earth का जो orbital shape है. That one complete cycle of eccentricity from least to highest to back to least, or highest to least and then back to highest, जो भी इससे एक cycle बनता है ना, that will take a time of 1 lakh years. In the time of 1 lakh year, the orbital eccentricity varies cyclically. This is called as the cycle of eccentricity. The second cycle is the cycle of obliquity. So हमने पढ़ा था the Earth's axis is tilted by how much of angle? 23.5 degree. This is also not fixed. ये भी fixed नहीं है. Over a period of time, continuously it increases and comes to a maximum of 24.5 degrees. And once it reaches the maximum, again it starts to decrease, comes to a minimum of 22.1 degrees. It happens over a long period of time. Earth's axial tilt is not fixed. It varies from the maximum of 24.5 to a minimum of 22.1. इसके बीच में ही घूमता रहता है. Okay, so like this. If this is 23.5, it goes up to 24.5 and comes back to 22.1. 24.5, 22.1. अभी बीच में है, 23.5 में है. इसको चेंज होने में कितना टाइम लगता है? एक साइकिल कंप्लीट होने में 41,000 years. 41,000 years is the time taken to complete one cycle, during which it changes from the highest to lowest and back to highest. Okay, कोई भी एक पूरा साइकिल का मान लो. हमारे ह्यूमन टाइम स्केल में तो ये ज़्यादा चेंज नहीं हुआ, इसलिए हमने 23.5 माना है. Okay, so since when we have started to observe this? In the last 1,000-2,000 years. टिल्ट वगैरह ये कितना है, ये सब तो ज़्यादा कुछ पता ही नहीं था ना. The third one is the cycle of axial precession. The cycle of axial precession. We have again assumed that the earth rotates completely in a precise manner. ये पूरा 100% precise manner में चलता है, ऐसे हमने assume किया है. ये नहीं होता है. During its continuous rotation, earth wobbles slowly like this. There is a slow wobbling. Wobbling मतलब ऐसे shake होता है ना. Where there is no perfect rotation, there you will see wobbling. Okay, so for example, let's say bicycle का जो टायर होता है ना, उसको ठीक से टाइट से नहीं फिक्स किया तो चलते चलते क्या होता है, ऐसे ऐसे शेक होगा. दैट इज व्हाट इज वॉबलिंग, है ना. तो अर्थ का भी जो नट एंड बोल्ट है वो ठीक से फिक्स नहीं हुआ है. रोटेट करते करते बहुत स्लोली ऐसे वोबल करता है. इट वोबल स्लोली. इतना स्लो है, एक वोबल कंप्लीट करने में उसको टाइम लग जाता है 26,000 years. One wobble will take 26,000 years. It's a very, very slow wobbling. That is what is cycle of axial precession. These are the 3 Milankovitch cycles. Cycle of eccentricity, cycle of axial tilt, cycle of precession. What happens because of these changes? The amount of sunlight which is receiving by the earth, that varies. Imagine when the earth is highly eccentric, the aphelion, perihelion positions will get impacted. Amount of sunlight which is falling on the earth will get impacted. Length of the day will also get impacted. Okay, tilt vary ho gaya to length of the day will get impacted. Seasons, the extreme conditions will vary, extremes of seasonality. When the tilt is too much, there is extreme season. When the tilt is moderate, moderate season. Not only that, it triggers long-term climatic changes also. Long-term climatic change. Natural climate change इसके वजह से होगा. Milankovitch cycles की वजह से होगा. Retreat and advance of glaciers will also get impacted. When the temperature, overall temperature is high, glaciers will start to melt faster. When the overall temperature is low, glaciers will start to grow, become longer. That is the advancing of glaciers. ये है मिलैंकोविच साइकिल्स, ठीक है. So we covered the basics related to the earth. In the next part we'll be covering the universe, the origin of universe, life cycle of stars, okay, solar system. ये सारा prelims related part ही है, quickly cover कर लेते हैं, and we will limit to only geographical aspect. Okay, so that will continue in the next class. Okay, next class topics: universe, stars and galaxies, and solar system. You can read from first chapter of G.C. Leong. G.C. Leong first chapter में ये सब दिया है, ये सब रेफर कर सकते हो. ठीक है, अगर NCERT पढ़ना है तो 6th स्टैंडर्ड NCERT. ठीक है, चलो, थैंक यू.